Ever wondered how scientific blunders have shaped our understanding of the universe? Imagine a world where every scientific endeavor was met with immediate success, every hypothesis confirmed, every theory validated without a hitch. Sounds perfect, right? But would it be as enlightening? If you think about it, it's through our mistakes, our miscalculations, our blunders that we truly learn, explore, grow, and yes, make groundbreaking discoveries. Now let's take this concept and apply it to the scientific realm. Science, in its essence, is an exploration of the unknown. It's a journey marked by curiosity, wonder, and the occasional stumble. And it is these stumbles, these blunders, that have often led to some of the most profound scientific revelations. Surprising, isn't it? But it's true. Scientific blunders, paradoxically, have been a catalyst for scientific discoveries. They've been the stepping stones that have allowed us to leap from one understanding to a deeper, richer one. Consider the monumental blunders made by some of the most renowned scientists in history: Darwin, Einstein, Kelvin, just to name a few. These were not just ordinary mistakes. They were blunders of colossal proportions. Yet they were the very blunders that helped shape our understanding of life and the universe. Darwin's theories of evolution, for instance, were met with widespread controversy and rebuke. Einstein's cosmological constant was dubbed his biggest blunder, and Lord Kelvin's calculations of the Earth's age were off by millions of years. But were these blunders detrimental to their legacy or to the progress of science? Quite the contrary. Each of these blunders, in its own unique way, paved the path for a scientific revolution. They challenged the status quo, sparked debates, incited curiosity, and eventually led to a deeper and more comprehensive understanding of our world and the cosmos. So as you can see, scientific blunders are not something to be feared or avoided. They are, in fact, a testament to the relentless pursuit of knowledge and the audacity to question, explore, and learn. Now, brace yourselves as we embark on a journey through time to unravel some of the most brilliant blunders in scientific history. Let's journey back to the 19th century, where Charles Darwin's evolutionary theory stirred a revolution. In the midst of Darwin's groundbreaking work, there was one detour that didn't quite align with the rest of his evolutionary theory. This was his proposition known as the pangenesis theory. Now, what was this all about? According to Darwin, each part of the body continually emits its own type of small organic particles. He called these gemmules. He then suggested that these gemmules would circulate through the body and gather in the reproductive organs, where they would contribute to the next generation's characteristics. This theory was Darwin's attempt to explain heredity, variation, and development, but it was fundamentally flawed. It suggested that acquired characteristics could be passed on, a notion that goes against the central principles of genetics. For instance, if a blacksmith developed strong muscles from his work, according to pangenesis, his children would inherit these strong muscles. However, we know today that this is not how genetics operates. While the pangenesis theory was innovative for its time, subsequent experiments proved it wrong. Francis Galton, a half-cousin of Darwin and a renowned scientist himself, conducted a series of tests involving blood transfusions in rabbits. If the pangenesis theory was correct, the characteristics of the donor rabbit would be passed on to the offspring of the recipient rabbit. However, Galton found no such evidence, challenging the validity of pangenesis. Although Darwin's pangenesis theory was a blunder, it was not a wasted effort. It prompted more rigorous investigations into the mechanism of heredity, which eventually led to the discovery of genes. It was a stepping stone towards the development of modern genetics, illustrating how even mistakes can contribute to scientific progress. So Darwin's blunder was not a misstep, but rather a detour on the path to discovery. It was a testament to the fact that science is a process of trial and error. It's about formulating hypotheses, testing them, and refining our understanding based on the results. Darwin's blunder, in essence, paved the way for the discovery of genes and the understanding of heredity. Moving forward to the late 19th century, we encounter Lord Kelvin, who made a colossal blunder about the age of the Earth. Lord Kelvin, or William Thomson as he was known before his elevation to the peerage, was a brilliant physicist and mathematician whose work in thermodynamics was nothing short of revolutionary. However, even the brightest minds can make mistakes. Lord Kelvin estimated the Earth's age to be somewhere between 20 and 40 million years old. He arrived at this figure by applying his knowledge of thermodynamics to calculate the time it would take for the Earth to cool down to its current temperature from a molten state. It was an ingenious application of the science of his time, but it was also drastically wrong. Kelvin's calculation didn't account for one crucial factor: radioactivity. The discovery of radioactivity by Henry Becquerel in 1896, a few years after Kelvin's prediction, changed everything. Radioactive materials within the Earth's crust release heat as they decay, a process that Kelvin didn't know about and therefore didn't include in his calculations. This internal heat source means the Earth cools down much more slowly than Kelvin had estimated. In fact, it's still cooling down today, over 4.5 billion years after it first formed. This vastly greater timescale has profound implications for our understanding of geology and evolution. When Charles Darwin read Kelvin's estimate, he was troubled. His theory of evolution required hundreds of millions of years, not the mere tens of millions that Kelvin's calculations allowed. The discovery of radioactivity resolved this discrepancy, affirming Darwin's timescales and further supporting his theory of evolution. Kelvin's blunder was a crucial step towards our current understanding of the Earth's age. It shows how science progresses, not just through moments of eureka, but also through the correction of mistakes. Kelvin's error pushed scientists to look deeper, eventually leading to the discovery of the Earth's true age and the realization of the immense timescales of geological and evolutionary processes. Fast forward to the 20th century, where Albert Einstein, the genius of his time, made what he called his biggest blunder. Einstein, famous for his theory of relativity, was convinced that the universe was static and unchanging. To keep this notion intact, he introduced an element to his equations known as the cosmological constant. This was essentially a fudge factor that allowed him to balance out the gravitational pull of all the matter in the universe, thus keeping everything in a steady state. Imagine the universe like a giant cosmic-scale tug of war. On one side, you have gravity, pulling everything together. On the other side, you have the cosmological constant, pushing everything apart. Einstein's equations could then maintain a delicate equilibrium, with the universe neither expanding nor contracting. However, this concept was not to last. In the late 20s, astronomer Edwin Hubble made a startling discovery. Through his observations, Hubble found that galaxies were moving away from us in every direction. This was clear evidence that the universe was not static but expanding. Einstein was reportedly shaken by this discovery. He had introduced the cosmological constant, not because of any empirical evidence, but because of his personal belief in a static universe. Now that belief had been shattered. He discarded the cosmological constant from his equations, calling it his biggest blunder. But here's the twist. In the late 90s, scientists studying distant supernovae found that not only is the universe expanding, but its expansion is accelerating. Suddenly, Einstein's discarded cosmological constant made a comeback. It was the perfect candidate to explain this acceleration, representing a mysterious force we now call dark energy. Ironically, this blunder is now a key ingredient in our current understanding of the universe's accelerated expansion. From Darwin to Einstein, these scientific blunders have had far-reaching impacts. Let's take a moment to reflect on the fascinating journey we've been on, exploring the colossal mistakes made by some of the greatest minds in science. These blunders, while seemingly detrimental at the time, led to some of the most significant breakthroughs in our understanding of life and the universe. Consider Charles Darwin, whose erroneous concept of pangenesis, though dismissed, sparked further inquiry into the nature of heredity. This ultimately paved the way for the discovery of DNA and the birth of modern genetics, transforming our understanding of life itself. Then there's Lord Kelvin, whose vastly underestimated age of the Earth prompted a deeper exploration into geological time. His miscalculation challenged scientists to develop more accurate dating methods, leading to the discovery of radioactivity and a profound shift in our perception of Earth's history. And who can forget Einstein, whose cosmological constant, initially dubbed his biggest blunder, turned out to be a key component in our current understanding of the expanding universe. His error led to the discovery of dark energy, a mysterious force that continues to challenge and intrigue scientists today. These blunders remind us that science is a process of trial and error, a journey of exploration where even the wrong turns can lead to amazing discoveries. They highlight the importance of questioning, challenging, and even doubting established theories. It's through this process that science evolves, pushing the boundaries of our knowledge ever forward. These great scientists, despite their blunders, were pioneers. They dared to question, to explore, to make mistakes. And it's in these mistakes that new paths of discovery were forged, changing our understanding of life and the universe. So remember, in the pursuit of knowledge, there's no such thing as a bad question, a wrong path, or a brilliant blunder.